Hi, in this video, I'm looking at this problem here where we're given matrix A. I want to identify the identity matrix that's the same order, same size as A, and then evaluate what the matrix A post multiplied by I is and pre multiplied by I is. So part A is easy enough. We've got a square 2 by 2 matrix. So the identity matrix is given the letter I, and it's always a square matrix, and we're going to make it the same size as A, and its leading diagonals is full of 1s and 0 anywhere else. So if, for example, we had a 3 by 3 matrix, then I would have 1, 2, 3 1s on my leading diagonal, and the rest of them would be 0s. But we've got a 2 by 2, so we're not going to focus on this one, we're going to focus on this one. So now when we go to part B, and I'm going to do A times by I, I'm going to have my matrix A, which is the matrix -3, 2, 5, -4, and I'm going to multiply that by the matrix I, which is going to be 1, 1, and 0s anywhere else. So let's look at what happens when we multiply. So remember, when we're multiplying, I get focus on the rows of my first matrix and multiply them on the corresponding elements of my second matrix. And so row 1 with column 1 gives me 1, 1 position in my answer. So then I line up elements, so first element, -3, multiply the first element, 1, so I have -3, and then I'm going to add on the second elements, 2 times 0, which is 0. Then move on to the next column, -3 times 0 is 0, plus 2 times 1 is 2. That should be a 3. -3 times 1 is -3. Then we can move on to the next row and repeat it with both my columns. So 5 times 1 is 5, plus -4 times 0 is -4, and 5 times 0 is 0, plus -4 times 1 is -4. Where did I mess up? -4 times 0, that should be a 0. So that gives us our product. So that means that the product A times I, -3 plus 0 is -3, 0 plus 2 is 2, 5 plus 0 is 5, 0 plus -4 is -4. And we'll notice, if I compare that with my original matrix, that's exactly the same as A. Let's see what happens if I multiply the other way around, if I do I multiplied by A. So this time, I'm going to have my identity matrix 1, 0, 0, 1, and I'm going to multiply that onto A, which is -3, 2, 5, -4. And let's see if I can get my multiplying right this time. So now, focusing on the first row, going on the first column, 1 times -3 is -3, 0 times 5 is 0. 1 times 2 is 2, 0 times -4 is 0. Next row down, 0 times -3 is 0, 1 times 5 is 5, 0 times 2 is 0, plus 1 times -4 is -4. So that means that I times by A is going to be -3 plus 0 is -3, 2 plus 0 is 2, 0 plus 5 is 5, 0 plus -4 is -4, which, if we compare it again to my answer, is exactly the same as A. And that's the whole point of the identity matrix, is that any matrix multiplied by the identity matrix is just itself. It's the matrix equivalent of multiplying by 1. Things like 2 times by 1 is just 2. The other thing to note is multiplying by the identity matrix is commutative. It doesn't matter whether you pre-multiply, like we did here, or post-multiply, like we did here.